everybody, it's Mr. Oakes. So I'm going to talk today about solving equations that involve distributive property. Now, some of you may remember distributive property, some you might. So just a really quick refresher. Basically what distributive property is when I have a number that's multiplying other terms that are in a parentheses, that I'm going to distribute that number through multiplication to everything in the parentheses. So for example, what I'm going to show you first off is this first example, there's no variables. 5 times 2 plus 4. Now what we would normally do is we would add 2 plus 4, get 5 times 6, and 5 times 6 is 30. But what we can do is we can actually multiply everything that's in the parentheses by 5. So 5 times 2 plus 5 times 4. 5 times 2 is 10. 5 times 4 is 20. And when we add those two numbers together, we get 30. So that's why distributive property actually works. So what we can do is we can use this when we are solving equations to help us kind of simplify being able to actually solve the equations. And in my classes, I usually suggest doing distributive property first before doing anything else. That way you get rid of the parentheses and there's less likelihood to make little mistakes through division or multiplying, little errors like that. So we'll start off with this first one here. This is just distributive property on one side of the equal sign with no negative coefficients or anything. What we have here is 1/2 times x plus 24 equals 21. So what I'm going to do is I'm going to just distribute the 1/2 through the entire left side of the equal sign. Basically everything that's in the parentheses is going to be multiplied by 1/2. So the x is going to be multiplied by 1/2 and also the 24. When we do this, we get 1/2 x, because that's all we can do when we have a number times a variable, is just put them together, plus, well, half of 24 is 12. Nothing happened to the 21, so we're just going to put equals 21. So we're going to keep that as is. Now, I go through a number of questions as I go through solving an equation. I do them quickly in my head, but I also suggest them for my students as they go through equations to kind of help them figure out what do they do. So the first question is what we already did. Is there distributive property? If we say yes, then we do the distributive property. We distribute the number through the parentheses, get rid of the parentheses. The second question I always ask is, does this equation involve fractions? If the answer is yes, well, we have three options when dealing with fractions. First, we could just work with the fractions as is. Basically find common denominators and work with the fraction as we would, doing addition, subtraction, multiplication, or division. Most students don't like to do that. The second option is to change any fractions to decimals. Now, a lot of students like to do that, the problem being, though, that not all fractions come out to a nice decimal. We could do that with this one. 1/2 does come out to a nice decimal, but I'm actually going to use my third method, which is called eliminating the denominator. This is my personal favorite, but it really depends on the person. And all that basically says is I'm going to multiply everything in the equation, the entire equation, by a number that is able to get rid of any denominators that I have with any fractions. Sometimes I'm lucky there's only one denominator, so I know exactly what I'm going to multiply everything by. Sometimes I have to look and figure out what the least common denominator is between all the fractions. In this case, we only have one fraction, so there's only one denominator. It's a 2. So we're going to multiply the entire equation by 2. So you'll notice I put parentheses around this and I'm multiplying it by 2. Really what I'm doing is I'm setting up another distributive property problem. But this time, instead of just going to a small group, it's going to everything. And I've set it up. It's not something that the equation already had. So I'm going to do 2 times 1/2 x. I'm going to do 2 times 12. I'm going to do 2 times 21. Now 2 times 1/2 x just becomes x. 2 times positive 12 becomes a positive 24. And 2 times 21 is 42. Now, I've reduced everything to basically a one-step equation. So what I would then do, there's more questions I would ask. The next question I would ask is the variable, are there like terms on one side of the equal sign? No, there aren't. Is the variable on only one side of the equal sign? Yes, it is. If it is, I don't have to do anything more. Is there addition or subtraction on the same side as the variable? There is. I'm adding 24. So what I would do is I would perform the opposite operation. This is addition, so I'm going to do subtraction. So I'm going to subtract 24 from both sides. So our 24s are going to cancel out. Our x variable is going to come down. And 42 minus 24 is 18. Now, even though we're basically done, just quickly, as I'll say the other questions I do. The next question would be, is there multiplication or division on the same side as the variable? No, there's not. Is our answer in the form x equals some number? Yes, it is. The last thing I would do then is I would perform a check. I'm not going to do it right now, but I could do it on the paper, I could do it in the calculator, and just really make sure that my answer is correct. And that's something you should always do. You should really make sure that you check your work, because sometimes you might have made a little error along the way. Maybe you made a little misstep, maybe you did your computations, you had a little error in it, but it's always good to make sure to check your work. So, my next example, I have a negative, and not only do I have a negative, I have a decimal. But my steps are still going to be the same. Okay? It's just that now I have to remember that when I'm multiplying by a negative, I'm going to be changing the signs of anything I'm multiplying. So if I multiply something that's positive, it's going to become negative. If I multiply a number that's negative, it's going to become positive. So I have here negative 2.5 times the quantity 4x minus 4 equals a negative 6. So a couple of negatives in there. We're going to distribute, because we have distributive property. I have a number multiplying terms that are in a parentheses. So I have negative 2.5 times a positive 4x. That's going to come out to a negative 10x. Negative 2.5 times a negative 4, that's going to become a positive 10. Not multiplying the negative 6 by negative 2.5, so that's going to remain. Equals negative 6. Do I have any fractions? No, I don't. Do I have like terms on the same side of the equal sign? No, I do not. Is the variable on only one side of the equal sign? Yes, it is. Is there addition or subtraction on the same side as the variable? Yes, there is. I have a plus 10. So I have to perform the opposite operation. I have to subtract 10 from both sides. Subtract 10 here, subtract 10 here. We didn't do anything with that first minus 10x, So we're just going to bring it down. These 10s cancel out. You see I'm trying to make this as colorful as possible. Equals -6 minus 10. I'm starting off negative and then I'm going more negative. So my answer is still going to be negative, and then I do 6 plus 10 gives me 16. Do I have multiplication or division on the same side as the variable? I do. I'm multiplying x by -10. So I'm going to perform the opposite operation. I'm going to divide both sides by -10. So when I do that, the 10s cancel out here, make it a little clearer. So I'm left with x. Now, if I leave this as a fraction, I can simplify. I know that it's going to be a positive because I have a negative divided by a negative. 16 over 10. I know that both of them can be divided by 2. 16 divided by 2 is 8, and 10 divided by 2 is 5. Here's the thing. We started off with decimals, so if we start off with decimals, we kind of want to end with decimals. So what I'm going to say is, or I'm going to do 8 divided by 5, and that's going to give me 1.6 as my answer. Usually either one of these will work, but usually you want to make sure that if you start off with the decimal, that your answer is in the decimal form. If you start off with fractions, then your answer should be in a fraction. And sometimes it's actually just a little easier to have things as a fraction in general, because sometimes you're going to get a decimal that goes a little, it just keeps going on. It's repeating, or it just travels on, and maybe you don't see the pattern right away, but you kind of have to put like a dot, dot, dot. It's better just to leave it as a fraction sometimes. This time though, that's not too bad. My last example, we have distributive property on both sides of the equal sign. We're just going to do what we've been doing. 3 times the quantity x plus 2 equals 2 times the quantity x plus 5. You only focus on one side at a time. Okay, I'm not going to distribute all over the place. I'm only distributing. This 3 only goes to what's in this parentheses. So 3 times x and 3 times 2. 3 times x is just 3x. 3 times 2 is a plus 6. So then I'm going to go and look at the other side. Alright, put my equal sign. And now I'll distribute the 2. I got to do 2 times x, 2 times 5. 2 times x is just 2x. 2 times 5 is plus 10. I ask my questions. Do I have fractions? I have no fractions. Are there like terms on the same side of the equal sign? I only have a 3x and a plus 6 on that side. They're not both x terms. They're not both constants. Not like terms. 2x plus 10. They're not both constants. They're not both variable terms. Therefore, no like terms. Is the variable on only one side? Nope. It's on 2 sides. So I have to look and say, well, which coefficient, 3x or 2x, which one of those has the smaller coefficient? Obviously it's 2x. So I'm going to add the opposite, meaning this is a positive 2, so I'm going to add a negative, or basically subtract from both sides. So minus 2x minus 2x. That cancels out. Here, 3x minus 2x is just x. Didn't do anything to the 6, so I'm going to write plus 6. equals, that canceled out, so we're just left with 10. Do I have addition or subtraction on the same side as the variable? I've got addition, so I'm going to perform the opposite operation, which is subtraction. So I'm going to minus 6 from both sides. And our answer is x equals 4. And that's solving equations using the distributive property. Now, if you have questions, you can always leave a comment, and I'll try to answer you as best as I can. But if you want to keep updated on these videos, please like and subscribe. I'm always open for suggestions for videos, and I really hope that these things help you. I'll move to the side a little bit again. Again, you got to remember, math is about patterns. So once you kind of have an idea of how to do something, or at least have a method that you feel comfortable with, these things will become easier. It's all about finding that pattern and taking advantage of it to solve questions, no matter how difficult they are, because once you recognize that pattern, you have the secret to answer those types of questions. I'm Mr. Oakes. I hope you keep learning, and I'll see you in the next one.